Hi everyone. So first of all, thanks for being still here. It's Friday night, I know you're tired, and maybe last night you stay out late, so thanks for being here. So as he said, my talk is about lazy loading and madness. Um, I am Massimiliano Marcon. I work as a web engineer at Nokia Maps, and what I do with my team is basically building city pages and place pages on Nokia Map, and you should definitely check them out because they are awesome. Apart from that, today I'm really here to talk to you about how your JavaScript code can be structured and lazy loaded in order to perform better when your application, especially if it's a complex web application, loads. So basically, what is the problem here? This is one of the problems we are trying to solve. Who has done this at least once in their web dev career? I did. So essentially, what the fuck? We want to avoid this mess. This could be another solution. So we take the whole application, we pack it together in a single file, and we serve it. Cool, just one HTTP request. Super fast, right? Well, what if your application is 500, 600 Ks? I think Google Maps is about 600K. Nokia Maps is a little bit more than 1 meg for the application. You cannot do that. It's going to take 30 seconds to load the application on a decently slow network connection. So essentially, the problem is that often we, and by we I mean web developers, we don't think about how the code that we deliver to the user can affect the performance of our application. And here by performance, I mean the loading time perceived by the user. I really don't care about the actual performance. I really care about what the user sees. So more code in your web application means more bandwidth to download it, but it also means more time for the JavaScript parser to parse it. And JavaScript parsers are becoming smarter, and they attempt to parse code only when it's when functions are actually invoked. But however, we still want to make it more efficient. So what we want here is definitely less code, as less as possible. Especially because, so do you think that code is actually necessary? Well, the answer is simple. It's not. We could very well just load what is necessary for the application to bootstrap and nothing else. And then load the rest later. So I guess the problem here now is how late is later? Well, let me tell you a story, the story of a happy user. So I, as a user, want to navigate to, let's say, a Maps application. Let's call it Nokia Maps for the sake of argument. So I open the browser, I type in maps.nokia.com, and I hit the return key. What I expect, since I'm going to a map application, is actually to see a map. I don't care about anything else. What I want to see are the map tiles on my screen. So nothing else really. So I guess at this point, the step that the developer should take is making sure that the user sees the map as soon as possible. And maybe we want to pack it with a couple of more features, say zoom and pan, because users sometimes are annoying. The application is loading and they start scrolling up and down and panning. So we give them zoom and pan, okay. So what we deliver as the first step to the browser is what I'm going to call bootstrap code. At this point, the user is super happy because he's looking at his browser and he sees the map tiles. And he's perceiving the application as a fast application. So he will probably come back another time because the application is fast. At this point, we go to the second phase. And we start enriching the user experience. So what we do, we start loading maybe a couple of map layers. For instance, we have something that we call city exploration. It's pretty cool because for cities, you can hover a city and you get traffic information. You get information about cool restaurants, clubs on nice heat maps on top of Nokia maps. And also, another thing that we want to load is, again, some bootstrapping code for features that are not there until the user actually clicks on something or does something or searches on the search box. And this is in particular the case of the projects I'm working on, which are city pages and place pages. Most of the code is not required unless the user explicitly decides to enter that section of the website. So if we load everything at the beginning at this step, it may be potentially a waste of bandwidth. So how can we make it better? Well, what we could do is to load the remaining code on demand. So only when they are actually needed. For instance, we have many UI components, photo galleries, sometimes dialogues when we want to notify the user about something. Those things are never required unless the user actually performs a precise workflow or a certain number of actions. In addition to that, and our friend Stoyan mentioned that yesterday, another thing that we want to do to make our application more performant is to load shims if they are needed conditionally. And conditionally here is another way to say on demand, except in this case, the demand is not created by the user that wants to perform a certain action. Instead, it's created by a peculiarity that the browser we have to deal with has, which is being made by Microsoft. I meant not supporting a certain feature. So to summarize, first, we load only the code that is necessary for the application to bootstrap, to show something to the user. Second, we enrich the experience by lazy loading some additional features. And last, we load everything else on demand. So let me tell you another story to contextualize this a little and see how I first started thinking about this. So one day I'm there with my team and we are discussing about performance of our application. And we said, well, wouldn't it be cool if we could make our application faster? And specifically, we could investigate the possibility of loading some of the UI components that we have in our pages on demand. So we wrote that on a blue card. We have these blue cards for tech devs and for spikes. And we wrote that on the blue card, and we stuck the card on the wall and forgot about it. Then, a few months later, at Nokia Maps, we created a performance task force. And the job of the task force is to sit there together one afternoon per week, look at our code base, see how the application behaves, and find spots where it is possible to optimize to make the application faster to load and more responsive to the user interaction. So I'm sitting there, I'm looking at the backlog of the things that needs to be done for performance improvements. And I decided it was about time to pick up that very old blue card and do something about that. So I started thinking of how we could load code on demand. So the blue card says, possibly load UI components on demand. But what does on demand mean? Well, I think in general, by on demand, we actually mean on demand, which means when the user clicks on something or performs an action, then only at that point, we load the code that is required for the action to be performed. Wikipedia says, in distributed computing, code on demand is a general term for any technology that sends executable software code from a server computer to a client computer upon request from the client software. And the upon request here is key, is when the user clicks on the button or triggers a search. But how can this be accomplished how can we do it code-wise? Well, in general, I think that when you start working on a complex project, the best thing you can do is to organize your code into modules and use a AMD framework to load your modules. We had a nice talk about this yesterday. So say, for instance, you decide to use required.js. So in the required.js world, besides having the possibility of loading or asynchronous loading modules, another thing that you have is expressing dependencies. But there is another thing that you can do. You can actually load code on demand. And the way you do it in require is by using what they call in the documentation callback require. And just last month, there was a blog post by Ben Nadel about the possibility of doing this. In his case, he was looking at a little web application as an example, and specifically, he wanted to lazy load the frequently asked questions, but only when the user actually wanted to look at the frequently asked questions. So we were doing pretty much the same thing. So I was actually very happy to see that somebody else was getting interested in this thing. So let's look at some bit of code for a second. So this is one way you could do it. So this is like a small applications developed with require. We express jQuery as a dependency. And then we bind a click event to a button in the page. And only when the user clicks on the button, then we call the callback require. And when in this case, I'm opening a dialog. When the dialog comes back, the code for the dialogs comes back from the server, then I invoke the create function on the dialog that will eventually display a dialog box. And here, there is an example of how you could do the same to load shims, for instance. So let's say my application is all contained in that super duper app closure, and it requires the JSON object to do parsing and stringify of JSON. But there are some old browsers that don't support it. So if the JSON parse function is present, and I'm assuming in this example that then the JSON object is there, therefore I just pass it. I just pass the native object to the super duper app. If it's not there, then it's probably IE less than 8. Then I require the JSON shim. In this case, I'm using the one from Crockford. And then when it comes back, it becomes a global object, so I can just pass it to super duper app again. That will have the possibility of using it. And this only happens in the case of IE. Other browsers don't even bother in downloading that code. Unfortunately, many times you have to deal with a code base that has been there since forever. And it's complex, it's hard to mess with it. It was developed before AMD became a cool thing. So there is really no callback required thingy. So what can you do about that? Well, this was exactly my situation, unfortunately, when I started working on this optimization task that I mentioned in my story earlier. There was a big legacy framework where there is a custom way to define modules, namespaces, and classes, and there is no callback required kind of support that is already in place. So I decided to attempt some cleverness or some madness, depending on the point of view. Basically what I did, I drafted a little proxy object that the only thing it does is you can invoke functions or request objects to this proxy. And if the function or object is already there, means it has been loaded before. So the function, we invoke it, the object will return it. If not, it gets the code, add it to the proxy, and then do whatever it needs to do with the function or with the object. So the code is downloaded and executed on the flight. And this is what looks like in the same thing I was doing with require before in the previous example. So when the user clicks, I say I want to use the dialog object. When it's downloading, I invoke the dialog.create. But how does this work? Well, the code is actually pretty simple. We'll look at this is the most relevant part of the plugin, is the one that says, okay, the code is there, invoke it. The code is not there, get it and invoke it. So this first part says, if I'm invoking a function, then invoke it. Oh, and by the way, I'm using promises because I think promises are pretty cool and they look good in your code. So I created a promise object, and if I'm invoking a function, then I resolve the promise with the result of the invocation. If, on the other hand, I'm requesting an object, then I resolve the promise with the object itself. The second part is the one that gets invoked if the code is not there. So in this case, it's I kind of refactor my proxy object as a jQuery plugin because it was easy, and I decided at some point I will put it out there, so people are always happy to use jQuery plugins, unfortunately. And so I use getScript, but you could implement it in many different ways if you want. I get the script. In the done callback, I execute the function, and I resolve again the promise. And if it's an object, then I return the object. I didn't put it in here, I think. Oh yeah, there is also a callback in case the loading of the script fails. So in that case, I reject the promise. So the application that uses this sort of object plugin can be notified and act accordingly. There are things that I haven't implemented yet. This thing is still very experimental. I'm not using it in production. I will use probably part of it in production. But what it doesn't do is providing an event queue in case the user clicks multiple times or interacts multiple times with the feature that you want to load on demand. And so it'd be nice if there is an event queue, so in the end, when the code is actually loaded, then you execute all the events in series. I guess now you're all wondering, what's the performance of this thing? Because will this be fast enough? I guess it depends on the definition of fast. So studies have shown that for a user that interacts with a system, an action is recognized as immediate if it happens in about 100 milliseconds. So on a pretty slow DSL line, let's say 256 kilobit per second, you can load a 15 kilobyte file in about 65 to 120 milliseconds. So it is pretty immediate, I'd say. But then this is in theory, because in general, it depends on the amount of code that you're trying to load on demand. It depends on the performance of the network, because in general it may vary. The bandwidth may drop, the latency may increase. So in that case, what I'm trying to sell you as a benefit may actually degrade your performance, and it will destroy a good user experience that you've created so far. So let's try to relax a bit the definition of on-demand. So on-demand doesn't strictly mean on-click. That works great in a perfect world where bandwidth is infinite, latency is 0, and sorry, To avoid undesirable delays due to the network condition, we might load a functionality right before it's actually needed, especially if that functionality involves downloading lots of code. For instance, in the example you may have noticed when I showed you place page at the beginning, there was a photo carousel there. That carousel, to actually be implemented with the lightbox, the carousel, and everything, requires a decent amount of code. So what we could do here is, for instance, load the code when the user scrolls down to the carousel. If you do that, then the code will more likely be there when the user attempts to use it. You actually don't know if the user will use it, so it will still be a waste of bandwidth if the user decides not to do it. However, what can you do about that? So there are alternative approaches, which I think are definitely beyond madness. What we could do, you could try to estimate how the user connection is doing and base your decision of when to load code upon this information. How can you do that? Well, in JavaScript, you can do that, for instance, by having an image with a predefined size on the server. You download it asynchronously with a JavaScript image object. You look at the time it takes to load the image. And based on that, you kind of have a metric of how the user connection is doing. However, I decided to go even beyond this. And I'm not saying you should do it. Don't try this at home. But I guess because of my background, I just like to play with these things. So here we are loading code on demand. So why don't we use that code to actually estimate how the network connection of the user is doing? So what I did, I wrote a little compiling tool that takes a JavaScript file annotated in a standard way and splits it into a file that can be loaded on demand. And each of these files is annotated with the size in byte of the file itself. So when the plugin gets it, then it can look at how much time it took to download it, look at the size, and provide the developer with some metrics that can be used to determine when code should be preloaded. It's mad, I know, and it's on the edge. It's crazy. You don't want to use it in production, but again, I think it's fun to experiment with these things, and I think for sure this kind of stuff opens our mind to maybe other new approaches to optimization. There is also another thing that I learned about recently. How many of you knew about Windows.performance? Okay, 3 people. And so this is an object which has been available for a while, I guess, already. And it's supported in IE from 9, I think, Firefox, Chrome, Safari. So it has a bunch of metrics, but these two in particular, load, event start, and navigation start, can be used to get the perceived loading time from the user when the document, when the page loads. The tricky part about this is that, unfortunately, it doesn't work for asynchronous calls. It really only, the browser only sets it on initial page load. So you can get an initial estimate of the user connection quality, but you cannot keep an ongoing estimate. So now, before I draw my conclusions, do you guys have any question? I am open for discussion. Oh, it's really mad.
Did you ever get to ship any of this code, all of this code?
Now, as I said, it's not in production. Part of it will be, because we definitely want to load at least the, we are gonna look also at metrics like how the users interact with our page, but stuff like photo gallery, that's quite some code, but still something that I think that can be loaded on demand. So we are definitely going to use part of it in production. We are not gonna do mad things like estimating user bandwidth. That would be crazy. But you can try that. I mean, sure. Yeah, of course. Yeah, I guess, yeah. I can see your skepticism, but I'm skeptical too, but that doesn't mean that you shouldn't give it a try,
Oh,
right?
it's awesome that you try, actually.
Yeah.
It's superb.
Okay. Any other question?
If you don't put it in production, how do you verify? Do you have, what environments do you use to test your hypothesis?
Well, for instance, I can put it in my personal server, and I actually have a little demo, but that doesn't do much because it's really the code that you've seen in the previous slides. That works great. I mean, you load code in this network in 12 milliseconds, but it's really a small amount of code, and this network is pretty fast. So, as I said, part of it will go in production and we'll test the performance, but not all of it. Anybody else?
From which size of application do you recommend to add something like required JS? Because you also have overhead when you use it.
Mm-hmm.
So what's the size you should consider using asynchronous loading?
Well, I guess for sure your code base should be bigger than the size of required JS, right? and then I guess you want to test performance probably. I guess it's the developer's job to identify the trade-off between loading everything, blocking at the beginning, and loading everything, lazy loading everything, and using framework like required.js that allows you to asynchronous load modules. And the thing is that with require, it's not only about the fact that it asynchronously loads code. It's also a fact that you can keep your code in a nice way because you can structure it in modules, and then anyway you have the optimizer that can build a big package if you want to, if you configure it as it should be configured. And I forgot to mention when I showed you how to load code on demand with required.js that the optimizer doesn't touch the callback required. That remains as it is. So even if you run the optimizer, that code is still loaded on demand.
I was wondering, have you done any comparison with this synchronous loading and, for example, a different policy for caching for JavaScript? Would it make a difference, you think?
I haven't, but caching in general is something that you should always try to do, right? And as other performance improvements, like making sure that your DNS is fast and the resolutions doesn't take too much, like gzipping, one thing doesn't exclude the other and doesn't compete with the other. Okay. So,
did you get to, were you able to test this code, or did you get into this madness you mentioned by testing, or yeah, how is developing with the require.js or with that lazy loading?
you mean how difficult it is, or?
Yeah, or do you have always troubles with, yeah, with these callbacks and with the timing, or do you, yeah, is the pain really big, or is it okay to develop?
No, it's actually not. I mean, developing with required it's easy, and it's no trouble at all. And even if you use that on-demand approach, and then you see it doesn't actually work well for your case, you just switch the way you invoke required. Instead of using the callback, you use the other API for the function, and then the optimization will just pack everything together. So it will load everything together and not on demand. Did I answer your question? Okay.
And did you also try to load only portions of a whole class?
Yes, actually, the initial thought was, what if I could just load a single function on demand?
Mm-hmm.
And yes, I tried that. Works pretty well. But what if you want to load 100 single functions? It's 100 of HTTP requests. So I guess you want...
Make an array with a queue and then send the whole array to the server. And on
Yes,
the
that's
server side
definitely
script.
something that you could attempt. But that will also require some backend code that packs everything together depending on the format of the request, right?
Yeah.
But that's actually a pretty good idea.
Wow. And does it work well?
That I haven't tried.
Okay.
It may.
Yeah. Cool.
Well, I guess, sure. It's basically custom built on the fly, depending on the user interaction. So it seems a good idea.
Yeah. Okay. Interesting.
Okay, so in this mad presentation, I showed you how you could load potentially JavaScript on demand. I showed you that it is possible. It is easy. It may have benefits, but you should actually make sure that it does have benefits and it doesn't break your application or your user experience. So should you use loading on demand? Why not? But you should do it wisely. So if you are interested in these slides, please follow me on Twitter. I will tweet the link in a few minutes. And I will be also interested in some feedback. This is my first web dev conference, so I guess feedback helps. Even if I suck, just say it. And you could use this link, which is speaker rate, or just send me a tweet. I'll read everything. Thank you. That was fast.